We are in investigation 2.3, and what we are basically doing is, this is our getting ready or our warm-up. And so what the example is, the number of cars in the school parking lot changes as time passes during a school day. These graphs show two possibilities for the way the number of cars might change over time. What they want us to do is to describe the story each graph tells about the school parking lot, and which graph shows the pattern you expect. All right, so the very first thing that we have to do is, one, we have to identify the variables. So one, identify the variables. And in this case, the variables, according to the situation, is number of cars and time. So our two variables are number of cars and time. All right. The second thing, once we've identified the variables, we have to identify independent and dependent variable or variables. Okay, so looking at our situation, do the number of cars determine what time it is, or does the time determine the number of cars? And if you remember, we've been saying this over and over again, time is always going to go on the x-axis, okay? Because time is something that we can't stop. Number of cars we can stop. We can actually control that if we so chose, all right? But time we cannot control, we can't stop it, so it's going to completely regulate how many cars are there. All right, so time is my independent, number of cars is my dependent. All right, so what I'm going to do with that information is that I'm going to actually use that, and I'm actually going to label each graph. So this is time, number of cars, time, number of cars. Okay, once you get that information down, what we're going to do is we're going to start reading the graphs. And we're going to read each one and see which one seems to make sense with our situation. All right, and then we just have to explain why we picked that story to go with that particular graph. All right, so here we go. If you remember, we always read a graph, and I will make another note. So step 3, oops, label graph, and then step 4, read graph, left to right. Okay, so now we're going to get ready to go. So as I was saying, when we read a graph, you read a graph left to right. So what we're going to do is we're actually going to start reading these graphs by using the two variables. Now when you read the graph, you always start with the independent variable. And then you explain how the dependent variable is adjusting. So, for example, graph number 1. And let me change my color. All right, we'll just use black. All right. So we're going to say, as time is increasing. So, as time is increasing, the number of cars increases steadily. Then there's no more cars that are coming in for quite a bit of time, and then all of a sudden, a whole bunch of cars come in at one time, and then a whole bunch of cars leave at one time, and then we're back to whatever the other number was for another long period of time, and then eventually they start to leave all at one particular time. So that's one example. And remember, we're talking about a school parking lot. Okay, so does that make sense for what we would expect? Would we expect a large amount of cars to be coming in steadily for a while, stop, not a whole bunch of cars, but a good amount, no cars in there for a while, and then a whole bunch of cars come in, a whole bunch of cars leave, and then there's nothing leaving, coming or leaving, and then the last bit of cars all leave around the same time. So that's one scenario, okay? You can kind of see how that might work, but let's see what the second scenario says. The second scenario says all the cars are steadily coming in as time goes by. It reaches a certain point, and then there's no cars moving at all. And then at a certain point of time, all the cars start to leave slowly until there's no more cars left in the parking lot. All right? Now, thinking about an actual school, I would probably say graph 2 makes a lot more sense than graph 1. All right? Graph 1, my only problem with graph 1 is the fact that it's only a little bit of cars that come in, and then there's nothing, and then all of a sudden there's a ton of cars coming in, then a ton of cars leaving. Okay? I can't see that happening at a school where a whole bunch of cars are coming in, and then a whole bunch of cars leave almost right away. It doesn't make any sense. Even if it was a drop-off, and then a pickup, or a drop-off and then leave, I don't know. That just seems a little bit drastic. The second graph seems to make a little bit more sense to me, where the cars are just coming in, and then eventually there's no more cars coming, and then all of a sudden they start to leave slowly but surely. That just seems to be a much more likely scenario for a school than graph number 2. So, it's going to be graph number 2. And my story is the cars come in steadily, then stop coming, then after some time they steadily leave. All right, so that takes care of that part. The second part, how could you label the graph you chose so that someone else would know what it represents? I'm actually going to leave that part alone. I'm not going to worry about that. I was really more concerned about getting the top part set up and answering this question about which graph, and then writing out a sentence as to why. All right, so that we can get in the habit of doing that. It's not just a quick, simple response. I actually want a whole paragraph for an explanation. All right, so what we're going to do is, from this, I'm going to basically give you the next lesson, which is 2.3, where you're actually going to take several graphs in several situations and try to tie them together. All right, so it's taking what we've just done here and just giving a whole bunch of possibilities, and I'm actually going to give you the stories, and you have to basically try to figure out what goes with what. Okay.